Alright, here we are with a cubic polynomial that is of degree 3, and we're going to do a quick example on how to factor a cubic. And so, there's a couple things to keep in mind here. When you factor any polynomial, whether it's a quadratic or a cubic, the factors must be related to the factors of this constant. In this case, the constant is 56. And so if this polynomial is factorable, we need to consider all the factors of 56. 1's a factor of everything. 2 goes in here. I don't think 3 does. I think 4 does. 5, 6, 7 times 8 is 56. We could go on further. But for now, let's look at these factors. And because it's a negative 56, we also have to keep in mind that the negative versions of these integers could also be factors of this polynomial. I guess if we want to be thorough, 14 would work, 28 would work, 56 would technically work. My bet is that we're going to find a factor that is one of these smaller numbers, and it'll kind of trickle down and give us the other two factors, hopefully. So, the way we're going to find the factors quickly is use synthetic division, and we're going to basically test some numbers to find out if we have found a factor. And so, by using synthetic division to divide this quickly, when we substitute a 1 in here, we're essentially testing the factor x minus 1. We're kind of using division in a different context to figure out what the factors of this polynomial are. Our goal is to get a 0 here, and that 0 would represent the remainder. And if you think about it, if you get a remainder of 0, that means that it would divide evenly, and something that divides evenly would be considered a factor. So this is kind of our goal down here. So if we test 1, and by now synthetic division hopefully goes quick, 1 times 1 is 1, add the columns, 1 times 10 is 10, 16, 1 times 16 is 16. And this yields not 0. And so what that means is that 1, positive 1, is not a factor of this polynomial. So that's the only frustrating part about this, is that sometimes you do have to test a few numbers before you actually find a factor. And so if I test negative 1 just as quick, I get a negative 2. This is not looking good. This is negative 54. Again, this is not 0, and we have not found a factor yet. Now, maybe you're feeling lucky and you want to test 14, or you want to test 7 or 8 because you like those numbers or something. But if you think about numbers in general, there are more numbers that have factors of 2 than that have factors of 4. And so, in my experience, these smaller numbers generally show up more. So the next number I would test is 2. And just kind of keep plowing through this and cross your fingers, hope for the best. We got 11, we got 22, we got 28. I'm liking this. We got 56, and we have a remainder of 0. And we get excited because this 2 is a factor. And got to be careful how we represent it. The way that we represent this is, as a factor, is x minus 2. You could think of this written in a way where, what value of x makes that factor equal to 0. And so when we tested positive 2, it's represented as x minus 2, kind of fulfilling that standard form. The better part of this is we're actually almost done, because what we're left with here is x squared plus 11x plus 28. And we have a lot of techniques to factor quadratics, the two numbers that add to 11 and multiply to 28 are 7 and 4. And so we can write the other two factors of this. And this is the factored form of f of x. Take note too, just one last thing, I don't think I said it at the beginning. When you have a degree 3 up here, many times you'll get 3 factors. You'll never get more than 3. But you're usually going to get 3. We'll talk more about that in another video. Thank you. Have a good night.